I would rather see those children pull out that bead string than try to remember some thing that makes no sense to them. They will eventually be able to get rid of it. Okay. All right, here's a phase 2 assessment. Once you've started pulling away and weaning them from that, now see if they can just put these numbers on there. Where would they be? Now, at this point, they're still using a little bit of scale. That's going to go away, too. They're not going to need to do that once they start getting rid of the physical line. No scale necessary. You know. A game to play here, and we're just going to play this one. Get out a piece of paper and draw yourself a straight line. And that's going to be your empty number line. And start, and let me see. Put a 0 on one end and a 100 on the other, just to let you know that's what you got. And what I want you to do is figure out the quickest way to get from 24 to 82. And you may not figure out what the answer is and make one jump and write that. Okay. What I would like you to do is make jumps of 10 and then jumps of 1. Or you could make jumps of 10 or multiples of 10 and jumps of ones or jumps of numbers that are less than 10. Like you could make a jump of 7. But if you have to cross a decade, you can't go across it without coming to that next decade number. So if you want to go from 88 and you want to make a jump of 4, you got to make a jump of 2 and 2. Now, I'd have to explain that much more to the children and do a lot more examples. But I want to see how many leaps will it take you. And if children play this with each other, they're going to learn from each other. Now, Tina, you're going to come up and show us how you did it. She's going, this is certainly not something that her class would do. This is above what her kids would do, but she's in first grade. How would you do it? And of course, there's only one right answer to this, so everybody watch. Tina's going to have the right answer, and nobody else is going to.
You had to have a 0 on here?
You could, or if you want to not. You just got to get from 24 to 82 in the least leaps.
Are we supposed to be jumping
And you have to
once only?
Or multiples of. What?
You have to show the deck.
I just want to see what you do.
Okay. Well,
I wanna see
first
what you
grade,
do.
you know, so this
Yeah.
is how it goes.
And I love the way she's notating. And by the way, I want to make a point about the number line. When you first use the empty number line, it is a model for your thinking. It helps you think. Where we want to get to is the number line as a model of thinking. That the only time you ever draw it is when you're showing somebody else what you were thinking. So it's like notating your thinking. Okay, show us how you did it.
I started 24, and I added 10, 34, added 10 more, 44, and then I got to the deckable by splitting to the 6, and then 2 to get to the 52.
Okay. And how many leaps did, to where'd you get to?
52, is that where we're going?
No, we're going to 82, but that's all right.
Oh!
Hey, could you do it? Keep on going. Keep on going.
Okay.
That's my mistake because I didn't make myself clear. I'm sorry. But you know what? It's not going to make a bit of difference. She's going to be able to do it anyway.
That's good. Yes, this is the, yes. 82.
Yes, come on in. Yeah. Okay, now, how many leaps? We're going to assume that you did that right. because we know that you were right to 52. Okay. How many leaps did it take?
7.
7 leaps. Who can beat it? It got us there. Who can beat it? Who did it in less leaps? I know you did, Jackie. Come up and show us. And by the way, I'm so glad you did that, because children are going to do it that way when they first start. They're not going to see. They're going to forget.
They know it's
We got there. We got there. Yeah. On to 24.
I really like multiples of 10, so
Multiples
I had
of
to
10.
go to 30. Then I went all the way to 80.
This is really important. Many children will they're not comfortable with those numbers like that, so they want to get to that 30.
I like
Okay.
comfortable
Yes.
tens. Then I got to 82, so I did it in 3 jumps.
3 jumps. Can anybody beat 3 jumps? I got it, yeah. Oh, yes, I know Brandy can.
Well, I didn't do it that way, but I didn't see it that way.
Okay.
I did it with 3.
You can do it with 3. Can anybody do it with less than 3?
I didn't see it originally, but I've seen it.
Okay. You didn't see it originally.
I didn't know
Okay.
we could do minus yet. I thought we were still.
Yes. Yes. Now here's the interesting thing. Somebody in your class will see this. They will see it. It's amazing how they see that you really could go forward and come back. You really could. But look at the way it's notated. When you come back, instead of coming back this way, it comes back under. Just to let you know, I'm going backwards. I'm moving backwards on the number line now. So I could add 60. Because if I added 60, this child said if I added 60, I would be at 84, and then I could just come back 2, subtract 2, and there we go. Okay. So it's a good game, and it's a good assessment game, and I promise you your children will not get it in 3 and 2 leaps at first. They will jump by 10s, and then a lot of them will jump by 1s because they can't yet see. But the secret is in having them show their work to each other, and like somebody said, I didn't know that, but I saw this, and now I'm thinking I could do that. Yeah. Okay. Now that's phase 2. Pulling away. Phase 3 is use the empty number line, representing their thinking on the line using the least amount of jumps. And the cognitive benefit here is that the first number remains whole. You don't have to do anything to the first number except write it on there and put a dot. Cognitive economy, you know. And then you start using your knowledge of 10s and 1s. Some of you said, I know if I just get to the next 10, I'm more comfortable. Where's the next 10? Then I'm going to jump by multiples of 10. Is this not using your knowledge of 10s and 1s? Multiples of 10? Yeah. And then I'm going to, somebody else might say, jump to the nearest 10. Is that not using your knowledge of 10s and 1s? And I put underneath my notes here to say, see Common Core State Standards. Because it says in the Common Core State Standards that at the end of 2nd grade, please read them carefully. Most teachers who heard me say this, all right, by the end of 2nd grade, children will be able to add and subtract double-digit numbers using their knowledge of 10s and 1s. 80% of the teachers I say that to says, see, I told you, we have to teach the standard algorithm. It says so right there. Actually, you know what it says? It says don't. It says don't teach the standard algorithm because you can compute this without any knowledge of 10s and 1s. You don't have to have any knowledge here. You've got kids do it all the time. They go 7 and 5 is 12, write your 2, carry your 1. There's absolutely no need for carrying. Carry your 1. Is that a 1? No. 1 and 3 is 4 and 4 is 8. So the answer is 82. Was any knowledge of tens and ones used in doing that? Absolutely not. Read your Common Core State Standards.